So this gives me the ability inside of Access Data's Registry Viewer to interpret the date and time value that you see inside of the value data itself. Now back to the point of the key or subkey holding a last modified time. Here you can see that the last time this particular subkey was updated with any of the values was on 12/7/2014 at 23:36. So it remains consistent that fundamentally the subkey and keys only maintain the last time that the subkey was updated. Inside of the live registry there is a hardware subtree that's not viewable inside the static registry, and once again this subkey is only viewable when Windows is actively running, and you can view this inside of Registry Editor or with other applicable tools. Looking at regedit in a little bit more detail, we look at the SAM file or the SAM hive itself, Security Accounts Manager, and you can see that the permissions do not allow us to look any further into the SAM, whereas before in previous slides we look at the contents of the user subkeys and the V and the F files that are contained therein, and allows us to look at the full structure of the SAM hive. So again, it's very limited in this view. When we look in the view of EnCase, the screenshot, again we see the full structure of the SAM hive, starting up here at the SAM subkey, going down into domains, accounts, and so on. Same thing is true with Access Data's Registry Viewer, and again the version that I'm using is 1.8.0.5, and it is compatible with Windows 10 as I had mentioned previously. Again, to be very clear about the structure or the layout of the Access Data's Registry Viewer, you can see the left pane displays your keys and subkeys. The right pane reveals your values, and that's value name, value type, and value data. And the bottom is your properties, and you can see the content of the values in some cases interpreted within that lower left-hand pane. And then finally you have the text values, and of course if you right click on any of those bytes contained therein, that you're provided with options to view the content of those hex values with an interpreter. So next we're going to make our way into the bulk of this presentation, which is focusing on the Windows 10 registry. So the first area that we're going to take a look at are the time zone settings. This is a critical element of any forensic examination, and it's one that you really should look at the onset of any forensic examination. That includes a live forensic examination or any type of static or dead box forensics examination. So the reason that we want to do this is twofold. First of all, let me digress for a moment and stress the importance of looking at the current clock settings through the BIOS. The reason that you look at the clock settings through the BIOS is to determine any type of variance between real-time, current time, and what the clock settings are currently set at. So for example, if there is a 4-minute variance in the clock, that is something that you'd want to note, that the system clock was 4 minutes off. That is vastly different from the time zone settings, which are more applicable and akin to regional settings, meaning what is the time zone offset from GMT or UTC. So the default file system in Windows 10 is again NTFS, and that's been largely consistent since Windows NT, Windows XP, and so on, and they utilize the file time format. And as I previously mentioned to you, the file time format is actually stored on the disk in UTC or in GMT format, meaning an offset of 0 from GMT or UTC. So in order to correctly interpret the date and time is largely dependent on the correct offset from GMT as it is applied to the evidence in your case. The time zone information is found in the system hive, and it's under the system control set followed by a number, and we'll cover that in a minute, control, and then time zone information subkey. Most of the values, they are similar to Windows versions of late, from Vista onward mainly, with the exception of a few new enhancements here and there. The first thing to determine is the current control set. The current control set is actually stored in the system hive in the select subkey, and as you'll see on the screen, there is a screenshot and a highlighted value here of current. And the current value shows us that the value data is hexadecimal 00000001, which is a decimal value of 1. Inside of the system hive, it's not uncommon that you'll have two different control sets. You'll have control set 001, and in some cases control set 002, or in some cases even more than that, depending on the Windows version. In the current release of Windows 10, there is only one control set. So that control set is 001. That's important because in order to determine the correct time zone offset, you need to go to the correct control set. Next, you're going to navigate to System Control Set 00 number, in this case 001, Control, and then the Time Zone Information subkey. And once you make it to the Time Zone Information subkey, you can explore these values in greater detail. You'll notice on the screen that you have a series of values stored inside the subkey. Notably, the one called Time Zone Key Name gives you a pretty good indicator as to what the current time zone is on that local machine. The daylight name and standard name, they both refer to TZRES.DLL, and with a string identifier. So I'm going to go back one slide so you can see that, and you'll see here that it refers to, for daylight name, TZRES.DLL 191 is the string value, and then for standard name you'll see TZRES.DLL 192. It's referring to this DLL, which actually stores the time zone settings and values inside of this DLL file. So when we go to a website such as nearsoft.net and the URL that you see on the screen, you can see the DLL references for Windows 8. At the time of this writing, I couldn't find anything for Windows 10, but TZRES.DLL for Windows 8 is pretty accurate to Windows 10 as well, at least for the time zone string values within the United States. So as we look inside this particular reference here for the string text, we see a series of string IDs. Here you see for 10 for the Azores, 11 for Azores Daylight Time, 12 for Azores Standard Time, and so on. And these string values identify which offset we're currently looking at. When we navigate out and we look at the two string values for 191 and 192, we find that 191 is applicable to Mountain Daylight Time, and 192 is correlated to Mountain Standard Time. The daylight bias is the number of minutes offset from the bias for the daylight savings time settings, and the standard bias is the number of minutes offset from the bias for standard, usually 0. Okay, so when we talk about the standard bias, the value is 0. What that means is that there's no bias, there's no difference in standard versus standard. So there's a 0-minute variance. However, when we look at the daylight bias, you'll see that it's got a hexadecimal value of FFFFFC4. This ends up being a long value, and so I'm going to use a utility here called base converter to appropriately convert these values. So when I use the base converter and type in these values of FF, 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 and then C4, you can see my value here in decimal is -60. And what that means is that the variance from standard to daylight is a minute bias of 60 minutes. And that is the obvious difference between standard time and daylight time is 60 minutes. The bias refers to the number of minutes offset from UTC for the time zone setting, whereas the active time bias is the number of minutes offset from UTC for the current time zone setting. When we come back and take a look at this slide here, you can see that the bias is currently recorded at 420, and the active time bias is interpreted as 420 as well. And the reason that the two are the same is in this particular instance here, 420 minutes from UTC or GMT is 7 hours. When you divide 420 divided by 60, you end up with a value of 7. So it is 7 hours from UTC, which is Mountain Standard Time. The time zone key name is the friendly time zone setting name, which we've already looked at, which is Mountain Standard Time. And then you have dynamic daylight time disabled. Dynamic daylight time disabled refers to the setting in which the user can start daylight time or utilize daylight time versus not using it and keeping everything standard. So in this case here, dynamic daylight time disabled, the value is either a 0 or a 1. If dynamic daylight time disabled is a value of 1, it means that daylight time is not going to be applicable to this local machine. If daylight time is turned on, meaning that it will change when daylight savings kicks in, then the value is 0. And in this case here, you'll see that the value is currently 0, which means that daylight savings is going to be utilized on this local machine. The next part of this subkey in the registry for time zone information is the standard start and the daylight start values. In the screenshot here, you see that you have a series of hexadecimal values that are interpreted for the start of daylight savings and also for standard. We're going to focus on the standard start value, which has the 0000, 0B, 0001, 00, and so on values. So let's take a look at this. The first two values that we see here on the screen is 00. This stands for the year. And what this means is that if the value is 0, it means it happens every single year. The next 2 bytes is 0B00. When you interpret that value from hexadecimal to decimal, you get a value of 11. And this value stands for the month. In this case, 11 is November. The next 2 bytes is 0100. When you interpret that from hex to decimal, you get a value of 1, which means that standard will start in the first week. So far we know that standard will start every year. It will start in the 11th month of the year during the first week. The next 2 values, the next 2 hex values is 0200. And when you translate that to decimal, you get a value of 2, which means that standard will start in the 2nd hour of the day, or at 0200 hours or 2 a.m. The next series of values refers to minutes, seconds, milliseconds, and the day, and you can see that the values are all null values of 00. So that is not applicable to this particular setting. So in the end, we know that standard will start every year in November during the first week at 0200 hours. In the next slide, we take a look at the value as interpreted by Access Data's registry viewer, and we see that the value in the key properties is interpreted as we just decoded them manually. and you can see that the standard start time is going to be the first Sunday in November at 0200 hours in November, and the daylight start will be the second Sunday in March at 0200 hours. The next area of the registry that we're going to look at is in the UsrClass.dat file, and this is another registry file that was introduced in Windows Vista. It's actually located in the username app data local Microsoft Windows directory, and from the start menu in Windows 10 you can go to the open field, if you will, that allows you to search the volume, or in Windows 10 actually even a broader search result. It will actually go out and search the internet if you're connected, and it will allow you to even type in commands such as regedit or calc or CMD for the command line, things of that nature. Some of these commands, not all of them, may result in an entry inside of the SID classes local settings software Microsoft Windows Shell MUI cache subkey, and in some cases you may have some evidence of a specific command being run by the user. Next, we're going to look at the Windows 10 recycle bin artifacts within the registry itself, not so much the recycle bin on the volume, but the registry artifacts. Not much has changed in terms of the items that are stored inside of the registry in Windows 10, but you will find in the ntuser.dat file and the path that you see up on the screen, there is a subkey that has a GUID for the volume, because each volume gets its own recycle bin in Windows. So really in the Bitbucket volume subkey there is a GUID subkey, and then inside of that subkey for the GUID for the volume you will find a nuke on delete value, and if it's a value of 1, that means it's going to bypass the recycle bin almost like a shift delete would if you were to delete files, and a value of 0 means it will actually move files or folders into the recycle bin. As you may recall in Windows, if you right click over the bin and go to properties, you can turn this option on and off by volume. As shown in the screenshot at the very bottom of the slide, you'll see that there are 2 GUIDs for 2 different volumes on the local machine. And in the second GUID, the one that starts with 70E7C111, you'll see that the nuke on delete has a value of 0, which means that files on that particular volume will be moved to the recycle bin. Remote desktop is another feature inside of Windows 10 that is still available to users. It essentially allows a remote user from another location to remote into the computer and essentially run the computer as if they were sitting directly in front of the physical computer itself. So the significance of this is obviously the defense of someone trying to claim that, well, I didn't download the child pornography, or I didn't hack into the network, or I didn't do this, I didn't do that. It wasn't me. It was somebody else that broke into my computer and did this. Well, you can certainly do a lot of forensic examination and analysis on various artifacts throughout Windows to confirm or deny this type of claim. One of the areas that you should definitely check is inside the registry in the system hive, following the path that you see on the screen to the terminal server subkey and looking at the fdeny TS connections, and this is the remote desktop value that determines on whether this is turned on or turned off. If it is turned off, the value would be 1 as interpreted by the hex values, and 0 means that remote desktop is turned on. In the screenshot here you can see that remote desktop is currently turned on. As you are familiar, the Windows Firewall is normally turned on by default in almost all versions of Windows. Certainly Microsoft wants your local machine to be protected from any type of malware or attacks. As you'll see in the screenshots here, I've gone to the control panel and to the firewall and customized the settings for the firewall, meaning I've selected the turn off or turn on the firewall option, which brings up this screenshot here in the left side. Notice that you have firewall settings for private networks and public networks. In some cases, you may have more options if you're on a domain, and you'll have an option to run the firewall on the domain if you so choose. So the logging for the firewall, you'll notice that you have a series of subkeys that exist underneath the firewall policy, and we'll explore those in the next slide here. And you can see that the enable firewall value exists and tells you whether the firewall is currently enabled for that particular profile. If we look at the various instances that you may find inside of the subkey, you'll see all the different paths to the firewall policy values are listed for you on the screen for the standard profile, public profile, and the domain profile. And of course, the name of the value is enable firewall, and the value will be a 32-bit value. And when converted from hex to decimal, a 0 is off and a 1 is on. And again, these are all default values of being turned on for all of the possible profiles. In the live registry in the software hive, Microsoft Windows current version authentication, logon UI, and then last logon user, you will see inside of this subkey that there is a last logged on user value, and it indicates the name of the user is red, and the machine name is potentially also existent in this area along with the user SID, and this value will exist on a live machine. But when this machine is turned off and the user is no longer logged in, this is deleted once the machine is no longer powered on. So you'll have to grab this information from a live running machine if this is relevant to your investigation. So the session subkeys are created when the OS is running, and they are created for users who actually log into the local machine. So let's say that we have a couple of different users here. When user A selects the option to switch user, user B logs in and switches user, and user A logs back in. There will be 3 session subkeys, 2 for A and 1 for B. If user A and B log in and log off back and forth, there will only be 2 session subkeys. And then after a normal shutdown or even disconnecting the power, the subkeys are deleted. So here's an example within Vista, and Windows 10 should be relatively the same. When you go in and take a look at the machine through the live registry editor, you can see the logon UI subkey with the session data, and here you have an example of one user being logged into the local machine. In the view of the 2 subkey and the values, which is the second user, the B user, now being logged in, and you see a second subkey with a value of 2, and of course you see the corresponding values of John being logged into the machine. Alright, shifting gears slightly, Windows 10 stores the local user account information in the SAM hive. I mentioned local because domain authenticated accounts are stored a little differently than local authenticated accounts, and you will find them in the SAM domains and users subkey. Under the subkeys, you'll find a series of user folders that are written in hex notation. And as you may recall from previous courses or training, every single user in a Windows machine is assigned a security identifier. And that security identifier identifies that user not only on the local machine but also in a Windows domain environment. So before we talk about the RID, the relative identifier, let's talk about a SID momentarily. I've got a security identifier example here that will probably shed a little light on the significance of what we're leading into. And this is a full security identifier, a SID, for a user. The last couple of digits that you see at the very end of the SID is the relative identifier. Now, if I were to take the Windows calculator and drag it into the screen real quick, and I type in 500, I have this converted right now as decimal. If I convert that to hexadecimal, I see that the value is 1F4. Well, that's significant because when we look inside of the SAM hive itself and down here at these subkeys below users, we see that the value of 000001F4 is one of the subkeys that appears underneath the user subkey. And so this subkey value translates from 1F4 to 500. And that's significant because the data that we find inside this subkey will be applicable to the user who has a relative identifier of 500. When we take a look at the F value, we see that the data shows the name of the users in plain code Unicode text, and we see that the administrator is the built-in account on the local machine. And of course the RID is 500, which is pretty common in installation of Windows from NT to present. When we take a look at the same data inside of Registry Viewer, we can see that the data from both the F and the V values is interpreted for us, and we see the security identifier is 500, and of course we saw in plain text in the previous screen the administrator account, and that's being displayed for us inside of Registry Viewer, along with other information about the lost login time, the last password change, and so on. So we've talked about the accounts that authenticate locally, but when you have a domain account, they may not appear underneath the SAM domains and users subkey. Rather, they appear under this SAM domain and names in plain text, but you're unable to garner the user's SID name or the full SID or even the RID from this particular subkey. So you have to navigate to the software hive and go to the path that you see there on the screen, which is Software Microsoft Windows NT, not Windows, but Windows NT, current version, and then Profile List. And then in the Profile List subkey, you'll find that you have the value name of Profile Image Path. And when you look in the Profile Image Path, you'll see that the username is displayed for you in the value data, which in this case is C, users, and red. So it gives you a fully qualified path to that particular user. It's also worthy to note that the SID value name stores the actual security identifier, and that hexadecimal value, which is 26 bytes, can be interpreted to be a SID. There's many utilities out there that will allow you to do that, but you'll also notice in the security identifier subkey name off here to the left is the fully qualified SID as well. And in this case, I'm looking at a different user, not administrator, but a user called Red. Okay, also in the SAM hive, circling back to the SAM hive, you will find that you have a user password hint. This is in plain text that you'll find this in this value. So at the time that the locally authenticated account is created, you'll be able to enter a password hint, and if one is entered, then it's stored in Unicode in this particular value. Alright, in the SAM domains, accounts, users, there is a 32-bit hex value in the user tile. The user's login tile, the actual graphic itself, is stored inside the value data itself as a bitmap, regardless of the originating format. So Windows reformats that, and you can see there's an example or a couple of examples on the screen for users Dan Limited, and John Admin, and the value itself is stored inside of the value. At offset 12 within the value data, there's a 4-byte value, and it is the size of the graphic. So when you interpret that data, the 4-byte value, it will give you the logical size of the graphic itself in bytes. And then at offset 16 is the beginning of the action.